The appropriate overcurrent protection for 2-2-2 SER aluminum cable should not exceed 90 amps. Using a 100 amp overcurrent protection device is not recommended and could lead to issues during electrical inspections. The National Electrical Code, or NEC, provides guidelines for conductor ampacity and overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating due to excessive current flow. The ampacity of a conductor is the maximum current in amps that it can carry continuously under specific conditions of use without exceeding its temperature rating. The size of the overcurrent protection device must be matched to the ampacity of the conductor it protects. If the overcurrent protection device is too large, it may not trip or open the circuit in the event of an overload or short circuit, which can lead to overheating and potentially a fire. Aluminum conductors have different ampacity ratings than copper conductors of the same size. Aluminum has a higher resistance than copper, so it generates more heat when carrying the same amount of current. Therefore, aluminum conductors typically require a larger size than copper conductors for the same ampacity rating. When selecting the appropriate overcurrent protection for 2-2-2 SER aluminum cable, it is essential to consult the NEC tables that provide ampacity ratings for conductors. These tables take into account factors such as the conductor material, size, insulation type, and installation conditions. The NEC specifies that the overcurrent protection device shall be rated no higher than the ampacity of the conductor it protects. However, there are some exceptions to this rule. For example, if the ampacity of a conductor does not correspond to a standard size overcurrent protection device, the next higher standard size overcurrent protection device may be used, provided that the overcurrent protection device does not exceed 800 amps. In the case of 2-2-2 SER aluminum cable, the ampacity is typically 90 amps based on the 75°C column of NEC table 310.15. Therefore, the overcurrent protection device should not exceed 90 amps. Using a 100 amp overcurrent protection device would violate the NEC and could result in the electrical installation failing inspection. It is important to note that the specific requirements for overcurrent protection may vary depending on the local electrical codes and regulations. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that the electrical installation complies with all applicable requirements. Some additional considerations for selecting overcurrent protection include the type of load being served by the circuit. For example, motor circuits may require overcurrent protection devices with specific characteristics to handle the motor's starting current. The interrupting rating of the overcurrent protection device must also be sufficient to handle the available fault current at the point of installation. The available fault current is the maximum current that could flow in the event of a short circuit. If the interrupting rating of the overcurrent protection device is too low, it may fail to interrupt the fault current, which could result in damage to equipment and personnel. The location of the overcurrent protection device is also important. Overcurrent protection devices should be readily accessible and located in a safe place where they are not exposed to moisture or other environmental hazards. In summary, selecting the correct overcurrent protection for 2-2-2 SER aluminum cable is crucial for electrical safety and code compliance. The overcurrent protection device should not exceed 90 amps, based on the ampacity of the cable. It is always recommended to consult with a qualified electrician or electrical inspector to ensure that the electrical installation meets all applicable requirements. Following these guidelines will help to ensure a safe and reliable electrical system. Remember to always prioritize safety when working with electricity, and never attempt to perform electrical work if you are not qualified. Improper electrical work can be dangerous and can lead to serious injury or death. Always turn off the power to a circuit before working on it, and always use appropriate safety equipment, such as insulated tools and gloves. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Understanding ampacity and overcurrent protection is vital for anyone working with electrical systems. The NEC provides detailed tables and guidelines to ensure electrical safety. These guidelines are developed and updated regularly to reflect the latest industry standards and best practices. Staying up to date on the latest electrical codes and regulations is essential for electricians and other electrical professionals. This helps them to ensure that their work is safe and compliant. Continuing education courses and professional development opportunities are available to help electrical professionals stay current on the latest codes and technologies. These courses can cover topics such as grounding and bonding, wiring methods, overcurrent protection, and electrical safety. By investing in continuing education, electrical professionals can enhance their skills and knowledge, improve their job performance, and contribute to a safer electrical environment. Overcurrent protection devices are essential components of any electrical system. They are designed to protect conductors and equipment from damage due to excessive current flow. Selecting the correct overcurrent protection device is crucial for ensuring electrical safety and preventing fires. The NEC provides detailed guidelines for selecting overcurrent protection devices based on the ampacity of the conductors they protect. These guidelines take into account factors such as the conductor material, size, insulation type, and insulation conditions. By following these guidelines, electrical professionals can ensure that their electrical installations are safe and compliant. In addition to selecting the correct overcurrent protection device, it is also important to ensure that the overcurrent protection device is properly installed and maintained. Overcurrent protection devices should be readily accessible and located in a safe place where they are not exposed to moisture or other environmental hazards. They should also be inspected regularly to ensure that they are functioning properly. If an overcurrent protection device is found to be defective, it should be replaced immediately. Electrical safety is a shared responsibility. Everyone who works with electricity has a responsibility to follow safety procedures and to ensure that their work is safe. By working together, we can create a safer electrical environment for everyone. Remember, when in doubt, always consult with a qualified electrician. They have the knowledge and experience to ensure that your electrical work is done safely and correctly. The use of appropriate overcurrent protection for aluminum conductors, like the 2-2-2 SER cable, is especially important due to aluminum's properties. Aluminum expands and contracts more than copper with temperature changes. This can lead to loose connections over time if the connections are not properly torqued and maintained. Loose connections can increase resistance, leading to localized heating and potentially a fire hazard. Therefore, using the correct overcurrent protection, as specified by the NEC and other applicable codes, is crucial for preventing these types of problems. Proper installation techniques, including the use of antioxidant compounds on aluminum connections, are also essential for ensuring long-term reliability and safety. Antioxidant compounds help to prevent corrosion and improve the conductivity of the connection. Regular inspections of electrical systems, including checking the tightness of connections and the condition of overcurrent protection devices, are also recommended to identify and address any potential problems before they become serious. By following these best practices, you can help to ensure the safety and reliability of electrical systems that use aluminum conductors. Furthermore, it is beneficial to understand the different types of overcurrent protection devices available and their specific characteristics. Circuit breakers are resettable devices that trip when the current exceeds a certain level. Fuses are one-time devices that melt and open the circuit when the current exceeds a certain level. Both circuit breakers and fuses have advantages and disadvantages. Circuit breakers can be reset, which can be convenient, but they may also be more prone to failure over time. Fuses are generally more reliable, but they must be replaced after they blow. The choice between circuit breakers and fuses depends on the specific application and the user's preferences. Some applications may require the use of specific types of overcurrent protection devices, such as time delay fuses, which are designed to allow temporary overloads, such as those that occur when starting a motor. Other applications may require the use of ground fault circuit interrupters, or GFCIs, which are designed to protect people from electric shock. GFCIs detect small imbalances in current flow and quickly trip the circuit, preventing a potentially fatal electric shock. The selection of the appropriate overcurrent protection device should be based on a thorough understanding of the electrical system and the loads it serves. Consulting with a qualified electrician is always recommended to ensure that the correct overcurrent protection device is selected and installed. Remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes and to ensure that your electrical work complies with all applicable requirements. This can be achieved through continuing education courses, professional development opportunities, and by consulting with local electrical inspectors. By staying informed and following best practices, you can help to ensure the safety and reliability of electrical systems. And always remember that safety is the top priority when working with electricity. Never take shortcuts or compromise safety for the sake of convenience or cost. The potential consequences of electrical accidents can be severe, including serious injury, death, and property damage. Always take the time to do the job right, and always follow all applicable safety procedures. In conclusion, the correct overcurrent protection for 2-2 SER aluminum cable is 90 amps. Understanding the reasons behind this requirement and the broader principles of overcurrent protection is essential for electrical safety and code compliance. Always prioritize safety and consult with qualified professionals when working with electrical systems.